Okay, so now we move on to the next part of our lesson. We will now learn about linear regression. Okay, so what's linear regression? Okay, so in the previous section, you learned how to draw a scatter diagrams, right? So when a scatter diagram shows correlation, so basically you look at the scatter diagram and you verified whether there is correlation or not, right? So you check whether there's a positive correlation or whether there's a negative correlation. And I was also talking to you about some kind of a straight line, right? So I was like saying, if you try to draw a straight line and if most of the points can go through, then there's a stronger correlation, right, guys? So now in linear regression, what we do is we are actually trying to find that line. Okay, so we are actually trying to find that line, and it's also known as the line of best fit. Okay, it's also known as the line of best fit. So basically, you have your scatter diagram, and you're trying to draw a line that kind of like best passes through these points. Okay, so they say this is a linear model that approximates the relationship between the variables. Okay, so one type of line of best fit that is useful in statistics is the least square regression line. Okay, so what is this least square regression line? Okay, so they say this is a straight line that minimizes the sum of the squares of the vertical distances of each data point from the line. Okay, so don't worry about this statement. What they're saying here is they are drawing a line in such a way, guys. Now you can see this is the original point, right? Now over here, for example, this is the original point in the scatter diagram, but the straight line goes from down here, right? The straight line gives the value over here. Okay, so for this particular x1 value, when for x1, the real y the data point is over here, but the straight line gives the y value over here. Can you see? Okay, the straight line gives the y value here, and the real data point is over here. So do you see there is a small error? That error is what they have named as d1. And then again the next point, the second point is x2. Can you guys see? So for x2, the actual y coordinate is y2, but the straight line gives the y value a little bit above that y2. Can you guys see? Okay, so what we say is the values that we get on a straight line is kind of like the estimated y values. Those are like the values on the straight line are our estimated y values. So the real point is actually not on there. But the real point, can you see now when we are drawing the scatter plot, what we are trying to do is we are trying to kind of minimize these errors. Now you can see D1, D2, D3, D4. These are the errors, right? Errors in the sense the difference between the actual y value and the y value on the straight line. So we want to draw the straight graph, the straight line in such a way that these distances need to be kept minimum, because that's the error, right? Because our straight line is supposed to pass through all the points, but we can't draw a straight line to go through these all the points. That's not possible. It is not possible to draw a straight line going through all the points, right, guys? Okay, so because of that, we need to draw a straight line that will minimize, that will make these d1, d2, d3, d4 as small as possible. So that's what we call as least square regression line. So don't worry about those stuff. You learn some calculations to do that. Okay. All right, guys. So the regression line of y on x is written in the form y equal a plus bx. Okay. So actually now I told you that you will learn. Okay. So not in this exercise, actually in the next exercise, you will actually be learning how to get the least square regression line, like how to get a line that minimizes these errors. So the calculations will be will be taught you in the next exercise. So but in this one, you will be learning how to kind of interpret and work with the lines. They'll give you the straight line, and you need to know how to work with it. Okay, so the regression line of y on x is written in the form y equal a plus bx. Basically it's a straight line following the format y equal mx plus c, right guys? So over here you need to realize the x coefficient, basically the b value is the gradient, right? And the a value here is the intercept, right? Do you recall? Y equal mx plus c, m is the gradient, c is the intercept. Likewise, in y equal a plus bx, b is the gradient and a is the intercept. And guys, for these two variables, the intercept and gradient, there we have some very special interpretations, which will definitely be tested in the exam. So I will be giving you the interpretation. Okay, so they say here, the coefficient B tells you the change in Y for each unit change in X. Okay, this is really important. Okay, so I'll explain this to you in better terms. Okay, just going through this first. If the data are positively correlated, B will be positive. I think that is pretty much clear, right? I think just keep the statement aside for now. But if you check this statement, if the data are positively correlated, guys, positive correlation means there's an upward trend. A upward trend means a positive gradient, right? Do you understand? Positive correlation means B is positive, gradient is positive, right? That makes sense. B is the gradient of a straight line. A positive gradient means the graph is trending upwards. So a positive correlation. That's pretty much obvious, right, guys? Do you understand? And the next one, if the data are negatively correlated, what's happening? Negative correlation means your graph is having a downward trend, right, guys? A negative correlation means your graph has a downward trend. Downward trend means your trend graph has a negative gradient, right, guys? So a negative gradient means your B value will be negative. So I believe that part is pretty much obvious, right, guys? Okay, so now let's see. I'll explain to you. So this is something that they definitely ask in the exam. So interpretation. I will give this to you. Okay, so interpretation of the gradient. This is something you will be tested in the exam. So write this down. Interpretation of the gradient B. Okay, and write this down.